Hi everyone, I am Naveen. So my topic is design and implement a lexical analyzer and parser that verifies whether a ATC program is grammatically correct using the provided context-free grammar for mini ATC language. So these are the headings. So now we will study. So in this slide we are mainly focusing on introduction. So in this introduction part, we are now focusing on what we are de- what we are mainly wanted to do in this project. So assignment, automata theory is an important concept in compiler design. So lexical analysis and syntax analysis are major phases of compiler. In this project, mini ATC programming language is used. Lexical analyzer and parser are implemented. The system checks whether the given program follows grammar rules. So in this problem statement slide, we are mainly focusing on uh, what are the major problems we are facing. So what we are providing the solutions for that problems. So our major problems, and we are giving a solution, that is design and implement a lexical analyzer and a parser for the mini ATC programming language using the concepts of automata theory and context free grammar. The lexical analyzer should identify tokens such as, first of all, we should know what is the tokens and identifiers, keywords, operators, and delimiters numbers. So keywords is like one kind of uh, one kind of a what we say, it is act like a variable, but we cannot use it as a variable, because the variable is one kind of a container where on that container we are storing some kind of values. But here keywords are not that kind of thing to store something values, objects, something what something whatever things. So identifiers is a one kind of one kind of one kind of a thing, like in that variable we are in that so identifiers is a thing like what we are providing values to that container, that is called identifiers. So identifiers maybe starts with maybe starts with the numbers like 0 to maybe starts like 0 to 10, and alphabets like A to Z, that must be upper cases, and lower cases that differentiate must be there in these identifiers. So but here major thing is we cannot use like special symbols, and uh, before starting a numbers or alphabets we cannot use a underscore here. So numbers, we generally know what is numbers. And operators the thing operators is a thing we are mainly using in day-to-day programming. So the delimiters also know everyone. So parser should verify whether the given mini ATC program is grammatically correct according to the provided uh, uh, co- context free grammar rules. So in this objective slice, we are focusing on mini ATC languages, so context free grammar, and whatever and major things like to design a lexical analyzer for a mini ATC language, and to identify key identifiers, keywords, identifiers, numbers, operators, and delimiters. To implement a parser using context-free grammar to verify whether the input program is grammatically correct. To understand practical applications of automata theory. So in we are studying now like mini ATC language specifications. So for a mini ATC language specification, we should know about what is program structure and statement supported. So program structure, yeah, every programmer must starts with a begin and must be end with a must be program must be end with a end word. So the statement supports like declaration, assignments, and print statements. So first of all, what is a declaration? Declaration is a part where declaring something variable. Assignment statements like everyone should know what is assignment. Assignment is a one kind of operator where we are assigning a values to a variable. So print statement. print statement should know, every know who are doing a program, who are working with a program like things, those should know what is a print will do. So print will majorly displaying a thing what we are required. So lexical elements. So in this slide we are majorly focusing on keywords, identifiers, and numbers. For our required, numbers must be a non-negative integers, and so everyone should know what is integers. So but in a major context of integers, like we are using in this lexical elements should be a non-negative. uh, identifiers in previous slide I majorly explained what is identifiers and the keywords. In this they are given a list of in this slide they are given examples of keywords, like what we are using uh, uh, in this assignment, like begin, end, int, print. Identifiers I already explained that thing. So everyone know about what is DFA. So in this we are mainly using a DFA for uh, our major requirements. Sorry. DFA for number recognitions. Uh, rules rules for this DFA, like number must contains only digits. Non-negative integers are allowed. States like we are using a states like Q0, Q1, Q2. So Q0 might be a start state, Q1 will be accept state, and Q2 will be a dead state. So valid examples. So I already said that numbers might be non-negative integers. So here we can see this 10 to 15, 999. These are non-negative integers. So lexical analyzers. In this slide we are majorly thinking about what are the functions of lexical analyzers. So reads input character by character, removes spaces and new lines, and identifies tokens, classifies tokens into categories, sends tokens to parser. So context of free grammar, it is majorly used in mini ATC implementation part. So in this slide we are majorly focusing on what are the major components for implementing uh, CFG and mini ATC. So we are using a input buffer and token matching functions, lexical analyzers, parser functions, grammar validations. So important functions. Functions should know, everyone should know what is functions. So functions as a functions is function. So function is uh, one kind of what we say. mm, so let it be no. Match keyword, identifier, number, and expression and program. These are the functions. By this we are go through. So we are using a functions. So we are using functions because we are required some kind of a specific task. But by using a functions, we are utilizing uh, process by again and again and smartly. So majorly programmers are using a functions for to uh, decreases the time complexity and space complexity. So everyone should know what is functions. So functions is a thing. uh, by using these functions we are majorly reducing the time complexity and space complexity, because we are, if suppose we are not using a functions, we required so much amount of memory. So next slide is a recursive descendant parser. So before moving a recursive descendant parser, everyone should know what is a recursion. So recursion is a thing we are we are repeatedly call a function. So everyone should know that meaning. So in this recursive descendant parser, top-down parsing technique, each grammar rule is converted into function. Function calls each other recursively. Parser verifies whether input follows SVG. So here recursive descent parser advantages will be simple to implement, easy to understand, suitable for small languages. So this is the expected outcome. Before explaining this expected outcome, so I my may I my my wish is I should show the program like what we are implemented through a Python code. So before this is our Python program. So to run this program we should enter on a terminal part. So in this terminal part we are go through new terminal. So we are here, we are entering python app dot py. This is a dot py is the extension of that python. So here everyone should see the enter mini ATC program is appearing. So here we are providing a keyword like begin. So after begin we are giving a like int x. This is a int is a keyword, but x is a one kind of a identifier. So for that x variable we are providing a one kind of value like 10 plus 5. So after we are breaking a semicolon, and we are hence we are do a end step. So after this we are getting a tokens like begin, uh, keyword begin, keyword int, identifier x, and these are the major tokens we are get through this mini ATC program. So what I am what this is a thing what should I explain in this PPT. And this is a thing I am I am provided a screenshot here. So my next slide is conclusion. So in this conclusion part we are discussing right now, and until and unless I am discussed right now, these are the major conclusion parts are here only. The project demonstrate majorly the project demonstrate lexical analysis and parsing. Automata theory concepts are applied practically. Parser validates mini ATC programs using CFG, that is a common free context free grammar, sorry. Recursive descendant parsing is successfully implemented. The project improves understanding of compiler design concepts. So last one but not least, that is references. In these references, we have majorly taken information from us. From our guide, that is Gagan sir. So here we are taken information by him, and through his notes, and we are taken some kind of notes from our classmates, and we are taken a textbook like automata theory. And so we are done we are majorly we are along with this assignment we are some kind of problems what we are seeing in real world. So we also go through that problems, and according by getting idea from that real world problem, so we also implemented here only. So thank you, Anita.